Today I'm going to talk to you about a workshop that I did in Timișoara in Romania, and it was about abdominal echography. Echography is also called sonography. So what is echography or sonography? The name comes from the echo. So if we have a sound source and we have an object, the waves emitted from the sound source will travel and it will cut the distance between the sound source and the object in a fashion like this. And then they will hit the object. And then we will have two types of sound waves. Sound waves that will go through the object and propagate through the object, and another type of sound waves that will be reflected, like this, until they reach the sound source once again. By using this technique, we can measure this distance between the sound source and the object by knowing the speed of sound, assuming, for example, if this medium is air, then the speed of sound will be 340 meters per second. So by knowing this, we will measure the time taken by the sound waves to go to the object, be reflected, and come back to the sound source once again. So we will divide the distance by 2 because it's going to the object and then coming back, so cutting the same distance twice. So the velocity equals the distance over the time, then the distance will equal the velocity multiplied by the time. Normally, in this case, it will be divided by 2, and we will get the distance. This is called echolocation. So it is called echolocation. And this is the basis of the echography or the sonography. So the same technique can be used to assume the width or the depth of this object. So we will measure the velocity of sound through this object, and going and coming back, we can calculate the distance very easily. So this is how echography or sonography works. Now the workshop was about how to use the sonogram itself. So we will have a side view of the patient. So the patient will be lying down like this. So this is the chest area, and this is the abdomen of the patient. So we are having a side view, and this is the arm. Now the sonogram consists of the following. It has a screen on which the image is shown. The image of the sonogram is shown. It has a dock that has a keyboard and a mouse pad or whatever that lets you control the software of the sonogram so that you can apply some filters or measure certain distances on the picture itself. And the most important part is the probe. The probe is made out of quartz. It looks something like this. So we have a wire that transmits electrical signals, and the probe itself is made out of quartz, so it's very fragile. So you should be careful while handling it. And at the tip here we have transducers. These transducers will vibrate because of the electrical signals that they receive, and they will begin to emit the ultrasounds that propagate through the body tissue with a velocity of about 1,540 meters per second. And it goes through the body. So the procedure goes like this. You apply some gel on the probe in order to increase the area of contact between the probe and the skin of the patient. So you start putting the probe in an inclined manner with the gel, and then you start to move the probe towards the area that you need to scan, and then you put the probe in a vertical manner like this, and again there has to be enough gel to decrease the areas in which there is no contact between the probe and the skin for the efficiency of the sonogram. And then the transducers will begin to emit their ultrasounds. They will reach to the back, and then they will be reflected again, and then the sonogram will be created. And the image is seen from this direction. So it's not a side view, it's an upper view or lower view, like this. The shape of the sonogram has a conical shape. It always looks like that, and this is due to the fashion of the movements of the ultrasounds. So they are emitted like that, and this is why you have the shape like this, the shape of the sonogram. A final thing that we have to mention about the sonogram, if we have an object like this, for example, and we apply sonogram to this shape, we mentioned that we have transducers, and the transducers, each one of them will begin to emit the ultrasounds. So each transducer will target a certain point on the surface that it hits of the object, not actually the whole object. And then the pictures are put together in order to form an approximate picture of the actual object. So the pictures of the echography or the sonography are not very accurate to tell us the specific shape of the organs themselves. So for example, in this case we will have a picture that looks something like that, like this, and then here we will have different shades of gray, and we will not actually see the specific borders of the object. So we will not see the angles as we can see them here at all, because it's a combined picture from each transducer. Now, due to the advance in technology, we have different types of echography or sonography. We have 2D echography or B mode. Brightness mode is called. So it gives you pictures of cross sections. We have 3D echography that combines different 2D pictures in order to form a 3D picture. We have M echography or motion echography that actually helps us to understand the motion of the organs inside the body. So it takes certain pictures of the same organ at different times, and it sees the difference in distances, for example the movement of ventricles or atria and so on, so it detects the motion. Also we have Doppler echography that uses the Doppler effect in order to also specify the motion and the movements of the organs inside the body. And the Doppler effect is very, very obvious when we hear the sound of a moving car, a very fast moving car or a motorbike. You have the object here. If the object is stable, the sound waves will be emitted at equal distances from the body at all sides. But if the body is moving in this direction, for example, the sound waves become to or tend to be farther from the direction that it was stable at and nearer at the direction it's moving to. So this is why the sound begins to fade away when you hear a fast car. So when you see the car right in front of you, the sound is at its peak, and then when the car moves farther from you, the sound starts to fade away and then it disappears. So this is the echography or sonography. I hope it was clear for you, and until the next time, I thank you for watching and see you. As for the education, I created the YouTube channel Edu for free. When I was at high school, I was 16 years old, so that I can be able to help my friends in Egypt and other countries worldwide with the high school curriculum subjects that I do understand very well, like physics, chemistry, biology, math, English, French, German, and so on. And what really makes me happy is the increasing number of viewers, as the video views now are about 780,000 views and the subscribers are about 2,180, which is really great. And also the interaction of the audience with the constructive comments that actually helped me to develop the channel to the better more and more.